Okay, so today we're going to talk about what does fraction multiplication look like using models. And there are two different types of models that we're going to look at. We're going to look at fraction times whole number models, and we're going to look at whole number times fraction models. Now, we know that thanks to the commutative property that we can multiply in whatever order we want, and we still should get the same answer. And what I mean by that is 4 times 2 gives us 8. I'm actually going to write it down. But even if I switch those numbers around and make it 2 times 4, I still get 8. So really, when we multiply, it doesn't matter what order we multiply in, but the models are going to change, depend on is it the fraction that goes first or the whole number goes first. So we're going to start with the fraction times the whole number models. Now, a pattern to look for when we do fraction multiplication word problems is you are going to see blank of blank. What I mean by that is I could have a problem that says Miss Smith wants to eat 1/2 of the bag of candy. Okay. Miss Punjabi wants to drink 4/5 of her Sonic drink. Okay. So we're looking for a fraction of something. So whenever we see that phrasing, like 1/2 of 8, that tells me that I'm going to multiply. So I can replace that word of with a multiplication symbol. So 1/2 of 8 is 4, or 1/2 times 8 is 4. 7/10 of 6 is 4 and 2/10, or 7/10 times 6 is 4 and 2/10. Okay, so again, that's just that key word that we look for. Now I've got two models right here. Okay, when we look at models, what's going to happen is we are going to be breaking these models up into equal groups. So when I look at this picture, I see two different ways that I can break up these models. I can break them up into vertical groups. So if I break them up into vertical groups, that would give me 4 groups. There are 3 in each group. So that's a total of 12 shapes. But I can also break them up into horizontal groups. And if I break them up into horizontal groups, that's 3 groups of 4 in each group for still a total of 12. So if I have a problem that looks like this, and it says there are 12 eggs in each carton, how many eggs are in 1/2 of a carton? So there's our magic word right there, 1/2 of a carton. So we know that we are looking for 1/2 times the total number of objects that we have. And if I'm looking in a carton, that's one single carton, and I know there are 12 eggs in each. So this problem would be 1/2 times 12. Okay, but I need a model that represents that. So when I look at these two options right here, I know that I need to take 1/2 amount of this total of 12 eggs. And the left model is going to be a little bit easier to do that because I have 4 groups here, and 4 is easier to break in half than 3 would. If I had 3 groups here and I broke it into half, I'd end up with decimals and broken eggs and all sorts of things. So this model right here would be the easiest one to show. So here's what we're going to look at. There's a set formula, a pattern that you can look for when we do these models. And we always start by looking at the denominator. Remember, the denominator is the bottom number in a fraction. So your denominator is always going to represent the number of groups. And the numerator is going to represent how many groups you want to circle. So here's how this problem would look. I know that I have 1/2 of the amount, but when I look at this model, I don't have 2 groups. Instead, I have 4 groups. So I have to figure out, well, what is my equivalent fraction that would take me from 1/2 to something with a denominator of 4? So my scale factor would be times 2. And remember, whatever I do to the bottom, I have to do to the top. So that would be 2/4. So when I create this model, I've divided it into 4 groups, but I'm only going to circle 2 of them because that is what my numerator tells me to do. So I'm going to circle 1, 2 groups. And whatever is inside of those circled groups, that is your answer. So I have circled 1, 2, 3, 4, 5, 6 eggs. So 1/2 times 12 is going to give me 6. Okay, just another example. Let's say since I've already got these divided into 3, I'm just going to circle one of them. So if I asked you to write a multiplication problem that describes this model, I'm going to start with I have one group circled out of a total of 1, 2, 3 groups, times the total amount, which is 12, and that equals 1, 2, 3, 4, because there are 4 dots, 4 eggs circled there. Okay, so this is one type of model that we can see with fraction to whole numbers. Here is our second type of model down here at the bottom. We're going to start with this problem on the left, okay? And I have, in fact, I'm going to zoom in, so sorry for the pterodactyl noise. There it goes. Okay, so I have, in fact, already given us the problem that I want us to demonstrate here. So it is 3/4 times 2. So when I look at this model, I already have my whole number. These two represent my 2 wholes. But I need to break these wholes up into fourths. So this time when we have models that look like this, our denominator is going to represent the number of sections. And I'll show you what I mean by sections in just a moment. And then our numerator is going to represent how many sections that I want to circle. Okay, so kind of the same wording here, but we've just changed from creating groups to creating sections. So what I'm going to do is I know that I have to create 4 sections using these 2 wholes. So I think about if I have a total of 4 sections that I need to create and I need to evenly split it between 2 wholes, 4 divided by 2 is going to give me 2. So I need to break each of my wholes into 2 different sections. So now I have 1, 2, 3, 4 pieces. That satisfies my denominator. Now, before I move on to the numerator, I have to talk about the value of each of these sections. So I'm going to look at just one of them. If I've taken one whole and I've split it into 2 pieces, that means that each of those pieces has a value of 1/2. And now that I have those values, now I can pay attention to my numerator. My numerator is 3, so I need to circle 3 of those sections. And then my answer is going to be the value of the sections inside of my circle. So I have 1/2 plus 1/2 would give me 1. 1 plus 1/2 would give me 1 and 1/2. So 3/4 of 2 wholes gives me 1 and 1/2. Okay, now when I look at this one over here, I actually made a typo. I'm going to change that to be 9. Okay, so when I look at this model here, I see 5/9 times 3. So again, I have 3 wholes. Now, the reason I did this one differently, see how my wholes are touching right here, and this time my whole numbers have spaces between them. It doesn't matter if they're touching or if they have spaces. It's going to work the same exact way. So I have 3 wholes that I need to break into a total of 9 sections. So 9 divided by 3 is going to give me 3, which means I need to take each of these wholes and turn them into sections of 3. And then I have to think about, okay, well, what does each section have a value of? So if I've broken it into 3 pieces, that means each section has a value of 1/3. 1/3, 1/3. Okay. So now I can pay attention to my numerator. My numerator says I need 5 of these sections. So there's 1, 2, 3, 4, 5. Just gonna make sure I circle to the right spot. Okay, so now I can see that I have 1 whole amount circled and 2/3 of another one. So that would give me a final answer of 1 and 2/3. So 5/9 times 3 equals 1 and 2/3. So again, just the most important thing to pay attention here is our denominator represents groups or sections. The numerator is how many that we're paying attention to, how many we want to circle. All right, so let's move down to our whole number times a fraction. I'm going to stay zoomed in. Okay, when I think of whole number times fraction models, I think of them as like I'm making copies. Like I'm clicking on one object and I'm just hitting Control-C, Control-V until I get as many copies as I want. So what I'm going to look at is when I look at these models, I see that each of those circles looks the exact same. So I need to start by counting, okay, well, how many circles, how many copies did I make of the same object? So I have 1, 2, 3, 4, 5, 6. Okay, so there's my whole number. Then the fraction is going to be kind of depending on the problem, which one is shaded or unshaded. For our notes today, we're going to focus on the shaded portion. So the fractional part is going to be, well, okay, just look at one of the examples. What is shaded in just that one circle? And I see that I have 2 pieces shaded out of 3 total. So this would be 6 times 2/3. It's like I'm just making 6 copies of 2/3. I'm going to look at our next one down here. So again, I'm going to start with how many copies did I make? How many shapes do I see? So I see 1, 2, 3, 4. And then I'm just going to look at one of those, and it looks like I have 4 shaded out of a total of 10. So this would be 4 times 4/10. Looking at this one, again, I'm going to start with the copies. I have 1, 2, 3, 4 copies. And in one of the copies, or in each copy, there's 1, 2, 3 shaded out of 4 total. And last but not least, when I look down here at our next one, I see 1, 2, 3 copies. And in each of those copies, there is 1 shaded out of 1, 2, 3, 4, 5, out of 5. So this would be 3 times 1/5.